George Chung Kam Kwok is originally from Hong Kong, but I think we can claim him as an Irish native now because he's been in Dublin some 10 years, George?
Yes.
Yeah.
More than 10 years. 13, probably. Yeah.
So George did his master's at Trinity College Dublin, and then he went on to do his PhD. And I was his supervisor. His external examiner was Emma Ushioda, and he's had a sterling career since then in terms of his research. He's continued to work with a particular interest in quantitative methods, and he really shares his skills in our school. He's a very valuable member of the team, and I'm really glad you have him here this morning. So George, I'll hand over to you and you can share your screen and we'll see how we do.
Okay, thank you. Okay, share screen. This one. Share.
That's great.
Can everybody see it now?
Yeah.
Yeah, it's pretty clear. Yes.
Okay, cool. So I'm going to talk about research methods in English language teaching. Although the name is English language teaching, the methods or the skills that I'm going to talk about are pretty much applicable in a lot of social science context. So it is not only about English language teaching. So the first question is, what is research? So basically it is about we are going to do something and find the answer to the questions that we are being asked. So you can say there are like two ways of getting our answers. The first way, we of course look at what people did before and then summarize the literature and then find out what it is. Or there is a second way. We are going to collect our own data and see what happened in the data. And then we draw our own conclusions. So the focus of today will be on the second approach. So we are going to talk about how to collect our data or how to do empirical investigation. So it sounds awesome, but how to collect our data and then how to analyze it? I have to say the slides or the contents in this lecture, it is by no way exhaustive. I just want to present to you some major methods in English language teaching or applied linguistics or in the broader social science context. Okay, so this is the outline of today's lecture. Quantitative methods, we are going to talk about research design, experimental, what is it, and what is the difference between experimental design and correlational design, and how about survey? And then after briefly talking about these three approaches, we are going to talk about sampling techniques. And then we will move on to qualitative methods. In the qualitative method section, we are going to focus on focus groups. And then finally, we will be talking about mixed method approach. So quantitative, qualitative, and mixed. Okay, the first approach, experimental. Does everyone know what is a control group and what is an experimental group?
I think probably everybody here. I think, oh, because I think there's a microphone on. Let's see who's mic. Maya, could you turn off your microphone, please? Sorry. Can anyone contact Maya and ask her to switch off the mic?
I guess that you can like mute us all, then we can unmute ourselves.
That's what I'll do. George, you can unmute now. I had to place everyone on mute. Great.
Okay.
I think everyone will know what the control and experimental group is, I guess.
Okay.
Can everyone confirm that? Is that okay? We control versus experimental?
Well, actually, sometimes it like for me myself, like it's like a bit confusing. So what I've as far as I know, like the control group is like the main group that you are working with in your sample population, and the experimental group is that it's like training and testing data when we are dealing with corpus, I guess so. But correct me if I'm wrong.
Basically, I think the slides is quite explanatory, quite self-explanatory. Control group, if you break like your sample into two groups, one group you give them some treatment, and then another group they don't have any treatment. For example, using different teaching method, the control group would use the old method and the experimental group would use new teaching method. For example, whether Clio is better for learning English, and then the control group would be the one that has no Clio, and then the experimental group would be the group that has Clio. However, there are some problems with this method. And can anybody think of like any issues? Not necessarily ethical issues, but other issues.
I think as far as I've
Hello?
maybe she has a connection problem.
Oh, okay. Can anyone think of any issues or any disadvantages about this method?
I guess that we need to like to make all the groups in the same, for example, age group, in the same social background, same educational background. So maybe any kind of difference can cause a problem in the results.
Exactly. Some variables are really difficult to control. So if you miss one variable, then your experiment failed. And then there is also ethical issues as well. For example, why do some people have a better treatment than another group? Or maybe the treatment is not that good. So why would a group of people take more risk than another group. So there are also ethical issues to consider as well. So it is difficult control. It is difficult to control, and there are ethical issues.
Yes, I guess maybe, for example, if we applied a specific theory or a specific method to a group of people in terms of language learning, maybe by terror, applying terror, for example, or anything like that, in order to see the effect of mistreatment in learning language, let's say. This is like a very broad example, and we apply another method with other students by encouraging them and by treating them and so on and so forth. So I guess yes, ethically that will be that will ruin a specific group. So yeah, it won't be acceptable.
So then there are correlational and survey research. In correlational, we try to make everything being equals between the two groups, but it is more relaxed. And the treatment, maybe not, it depends on your research design, but so it is not that strict. So you just maybe use some statistical skills such as correlation or multiple linear regression or different types of regressions to try to formulate a relationship between one or more variables. But the problem is causality, correlation doesn't imply causality. There is one example I would like to ask. Surveys find that when the sales of ice cream increase, the number of people who drown is also increased. Why? So ice cream sales increase, and the people who died of drowning also increases. So does buying ice cream cause drowning?
No, I don't think there is a correlation between the two of these circumstances.
But why?
I'm sorry, but is
why,
it possible to repeat this part again? I'm sorry, but I lost you in this part. Is it possible to repeat the question or this part again? I'm so sorry.
Okay. There is a case where people find that when the sales of ice cream increase, the number of people who are drowned also increases. So the number of people who drowned increases, and the number of ice cream sales also increase.
Yeah, maybe they can draw a conclusion that there is a correlation between both aspects. That maybe that the ice cream includes alcohol or something.
Yeah. So the reasons behind it is because the weather is hot. The temperature is high, so people go to buy more ice cream. But at the same time, people also go to beach more often. And more people go to the beach, and more people get drowned, and more people buy ice cream. Of course, the sales of ice cream increases. So although they are both increasing in number, there is no causality. And what I would like to point out is there is a confounding variable, that is hot weather. So at the end of the day, if we find correlational relationship between two or more variables, we have to really think carefully whether it is because they have some kind of causal relationship, or because there is a third variable that affects both. So, and then finally, there are surveys. It is a general term. You can conduct a survey and then do correlational tests as well. So it is not mutually exclusive. They are not mutually exclusive, correlational research design and survey. But the most common type of survey is opinion polls. So you ask people how you think about something, or how you think about the quality of a particular product, or how is their experience in the classroom. So people tell you about their opinions, and you just count the number. So, however, there are different types of data. You can do experimental design, you can do a correlational design, and you can do a survey. But there are different types of different types of data, no matter which design you go for. So roughly speaking, we have two types of data: quantitative data, and commonly expressed in numbers, and qualitative data, recorded spoken data, like interview data. And then one of the example is, why do people choose a particular type of language? If they are multilingual, for example, why do people choose to use a particular variety instead of another one? Or why people lose interest in studying a language, etc. So
may I ask
yes.
a question in the
Yes.
previous slide,
Yes,
please?
of course.
So here, you have categorized the quantitative and the qualitative data. One is like on the number of people and so on and so forth. But here on the qualitative data, can't we deal with the recorded or spoken interviews or even surveys or anything like that? Can't we deal with them as a quantitative data as well? Like,
yes, exactly. Yes.
Yeah.
Yes. Can you give me an example?
Yes. So, for example, I have done a research like 6 years ago or more, and I conducted some interviews for all the seafarers in a specific place. Okay, and I applied this. Nemo? And I applied, sorry, and I applied the quantitative method on what I have gathered from the data, because these were all the seafarers in this specific place. Like they were only 6 people. Okay, and then I try to count the frequencies of the relevance of some technical jargon that they have said, in order to measure if this is the common jargon that is used in this specific situation or not. Yes. So this is how I conducted the qualitative methods, and to apply the quantitative method. So it's like a mixed method.
Yes, yes, very good example. Yeah. And so the qualitative and quantitative approaches shouldn't be dichotomous. So they are not categorical. Sometimes they are complementing each other, or sometimes you can treat qualitative data quantitatively. Another example I can think of is collocation. So you count the number and you count the number of occurrences where two or more words co-occur. So do people use, for example, do people use he can or she can more, such as when non-native speakers of English speak English, like in Hong Kong, we always mix up he or she because we don't make distinction between he or she in our language. We just have like one pronoun for both genders. And therefore, you may want to measure whether people tend to use he or she when they are speaking pronouns, when they are using pronouns. So this can be one of the examples to deal with qualitative data quantitatively, or some other approaches is like content analysis. People count the number of the frequency of a particular term, like your research. So the differences between the two sometimes depends on your research question and the context as well.
Excuse me.
Thank you so much.
Yes.
Yeah.
Excuse me. I have a
Can I add
question.
something?
Yes.
Okay, go ahead,
Go
Dream.
ahead.
It's okay.
Go ahead.
So,
Actually,
yes.
okay. Actually, thank you, Sam. In my research, I always use both of them, qualitative and quantitative data, because this is actually what professors usually recommend.
Yes.
Not only do I have to count in numbers, but I always have to get valid points why this was used, or qualitatively, or what is the significance of the qualitative data here in the research.
Yes. We will look at an example later. Perhaps you can also give your insights as well when we talk about that example. Sorry, I have to admit that I didn't expect
to Reem's point. Hello.
Hello.
Okay, this is Zaid. Can I add something to Reem's?
Yes,
the mixture
of course.
Between types of data. Well, actually, sometimes you will a mixture of quantitative and qualitative question types. So
Yes.
both categories have their strengths. I mean, quantitative facts and qualitative data can illuminate behind the numbers. Okay, so at some we cannot depend on just one type and skip the. Okay, we just need to get valid points at the end to draw our conclusion. Yeah, that's all. Much.
Yes. Cool. Very good point.
Can I add something very quickly?
Yes, of course.
Okay, so I think maybe the confusion is we are terming data as quantitative and qualitative. In my opinion, quantitative and qualitative are approaches to the data. That's how I perceive it, or that's how I see it. I have the data and I will decide how to deal with it. Is it in a quantitative method or a qualitative method? So that's how I use it, like what Reem said, and Yomna and Dina. I have to use both. They are both complementary. I'm, for example, doing quantitative data. I have numbers, and then I use the qualitative method in order to validate why the numbers are so and so. So yeah.
Yes. So I think since we are here, because I was supposed to talk the mixed method at the end. So, but since we are here, I would like to talk about the mixed method, and then we jump back to talk about sampling techniques. So I think just judging from what everybody has said, I think you are quite familiar with like different approaches here. So you can have first quantitative, and then you use qualitative to maybe find out why some data or some learners behaved in a particular way. So you just use quantitative data or quantitative method to show your readers a general view, and then you use a more qualitative approach to find out why. Yes.
Yes, exactly. Yes,
Yeah.
that's how I use it.
Yes. But sometimes sometimes people may give more weight to quantitative method, and then they use a tiny little bit of qualitative method, or sometimes it is the other way around. They use a lot of qualitative method, and then they use tiny little bit of quantitative, and or at the end, qualitative and quantitative are equally important, but it is just used in different order in comparison with the first approach. So this is just a summarization of like how we can use quantitative method and qualitative method complementarily. And then but I suppose like everybody seems to be very familiar with how to use mixed method, and then a qualitative approach, quantitative approach. So I think I won't waste time on this topic here. So I will jump to okay. And so the next aspects I would like to talk about is longitudinal research. So we have basically, I think everybody is familiar with it as well. Or has anybody done any longitudinal research like in the past? Can anybody like share with us her experience or her research?
No, actually, I haven't used longitudinal research, so yeah.
Yes, well, longitudinal research is like maybe that you have applied a method in specific period of time or on specific group, and then you reapplied the method or applied another method after a period of time. Yeah, yes. Well, actually, I've done that, but the problem is that here in Egypt, or I'm talking about Alexandria University, we are not so familiar with the names or the terms of the type of researchers. This is a problem because we don't actually take this kind of terminology. We do it, you know, we do self research and self search on the terminology and on the ways of the methods, how they are done, and so on. So yes, concerning the longitudinal research, I've done first of all like a survey research and a pilot study first on how like students in studying English as a second language in the visually impaired schools in Alexandria, how this is done, actually the process and the language planning for them. This was a pilot study, and I've done this on around 3 months or something. And then I reapplied the method, like what I have found out, the pros and cons that I found, and then I tried to I came up with my own model of how to apply the best methods for, or the best practices for the visually impaired students to learn English as second language. Then I had a group. We can call it like an experimental group, and I applied this method on them throughout a course that is designed by myself based on the outcomes that or the results that I have came up with in my pilot study. And afterwards, I applied this for again 3 to 4 months. This was the duration of the course for the visually impaired students. And what I found out that the success was actually around 90% or more. Yeah.
Okay, cool. So did you use any statistical tests to measure the effects of your method?
Yeah, well, actually, it was all based on the observations, the actual tests that I gave them, oral tests, because definitely the written test won't be applicable for their cases. And what I found out was actually based upon manual representations. I haven't relied on any kind of statistical tests because, again, as I told you before, that the point of the statistical analysis and so on, we do it on we do this on personal efforts. Like we do personal search and personal research to try to get the results, but we don't actually study this as a course, you know.
Oh, okay.
Yeah.
Okay. So I think here is an example about longitudinal research. So basically, we follow the same group of people and record their development over time, and then do it repeatedly at maybe 3 months interval, or can be the intervals can be in years, etc. So so the disadvantages is one of the disadvantages is the attrition rate. So people will just drop out, and then it is hard to follow everybody over a long period of time, and it is also expensive as well. Okay. And then there are also different types of longitudinal studies. And for example, one of them is trend studies. You just repeat cross-sectional studies. So sometimes it is so hard to follow the same group of people for a long period of time. So instead, people would, for example, we are interested in people studying English at primary school. So we look at primary 6 students this year, and in 3 years, we look at another group of primary 6 students, and then in 3 years, we again examined the primary 6 students. So there are 3 different cohorts, but if you want to know how primary 6 students learn English, or how they perceive their learning environments over time, then this can be some kind of longitudinal study that can make up for the panel studies, like the one we talk about following the same group of people. We normally call it panel studies or cohort studies. And then trend studies is we are also interested in a particular group of people, but it can be too costly to follow the same group of people. So we just do some adjustments to answer the same question, although it is not as accurate as the panel studies that we talked about. And then there is another approach called retrospective longitudinal studies, and it relies a lot on the respondents' memories. If people are asked to remember what happened 20 years ago or 30 years ago, then as you can imagine, the accuracy can be quite low. And then people may have selective memories as well. They may choose to report something or choose not to report something, and that also damages the validity of your data. So just different designs about longitudinal research. So so we are going to talk about sampling techniques now. So I'm wondering how many of you have already known like different sampling techniques, or because there is because I think many of you are quite familiar with different techniques I'm talking about here. I'm just wondering if I can present to you some software or some kind of maybe a statistic skill, or would it be better, or you want me to go on to talk about sampling techniques and some qualitative method and one or two examples in the rest of the lecture?
Well, actually, if you sent us like a software or anything, that would be great. But yeah, we'd like to know everything from you as well. But for me, I'm familiar with the random sample and saturated sampling. Yeah, these are the sampling techniques that I am familiar with, and there are other sampling techniques that I don't have in mind right now, but yes, I am a bit familiar with them.
So since
yeah,
we are,
but
yes,
the rest of us are not very familiar with it because my research is not does not center around using statistics, but I would love to know about them. So
okay. So since we don't have much time, and then even if I introduce to you some statistical methods that are quite popular, we may not have enough time. But let's say, can I ask you if you can, during the break, download a software called PSPP? You all know, you all have heard of SPSS before.
Yes, I've heard about SPSS, but
yes.
PSPP, this is very new for me.
Oh, this is actually just playing on words because it is free. So SPSS, you need to buy a license before you download it.
Yeah.
But I'm not sure if everybody has access to it, or so I think a freeware would be more appropriate or more suitable if like we would like to talk about some statistical skills using software. And so if you have SPSS on your laptop or on your device, it is fine. But if you don't, let's say, see if we can have PSPP or SPSS, and then we talk about some statistical skills. Should we
Okay.
after the break, maybe I talk about some sampling techniques, and then if we have enough time, we talk about some statistical skills that are commonly used in English language teaching research or applied linguistic research. Would it be a...
That
Yes,
would be
that
very
would be
beneficial. Thank you so
Yeah.
much.
Yeah.
So I know it is
Can I ask you
maybe a
question,
little bit...
please?
Huh?
Can you ask your question? Will you be able to send us your presentation?
Yes, of course. Yes, of course. Yeah. The slides will
Okay.
be uploaded.
No, the
Okay,
slides
thank you
are not
very much.
uploaded on the model. So thank you for your
Yeah, it will
initiative
be
for sending it to
uploaded
us.
after the class.
Okay, thank you so much.
Yes.
Okay.
Yes. And but if... can I ask you if you can download this software during the break? Sorry,
I've
it
actually
is supposed to be...
I've actually searched for it, but I didn't find a direct like link for downloading. So
Okay.
can you send us anything here?
Okay, just a second. I see if I can find anything.
Well, I think I found it online.
Dina, can you?
I'll
Yeah.
type.
Yeah, here is the
Okay,
link.
I'll type. Okay, thank you.
Yeah, but anyway, I think I would also like to talk about some free software for doing research as well. And so it's not completely different from our original plan. It's just things go quicker, because everybody seems to be like very familiar with different research techniques I covered here. So can we take a break and then we come back in maybe 25 minutes, and then I can know whether you have successfully downloaded the software, or if you have SPSS already, so don't bother downloading it. Then because the layout is very similar, basically identical, just some colors and some names, some buttons are different, but they are very similar to each other. Okay.
Okay, we'll try to download it in the break.
Yes. Okay. I will be back in 15 minutes, but do take your break. But if you have any problems, you can ask me.
Excuse me, is this the link where we can download the PSPP?
This is the link
one you
we
just
found.
sent me. Okay.
Is this the correct one?
I'm not sure. The link is different from the one I sent you. Download. Parent directory. Cancel. Okay. So this reader. We should have download. I share the screen with you. Just a second. I think it's maybe easier. So if anybody wants to take their break, and feel free to go. So here is. Yeah, can everybody see it?
Yes.
Yes. Here is the download button. This is the link that I sent you, and then here is the download button.
Okay, thank you.
And then you can choose your device.
Is it similar to the R?
Oh no,
program?
our programming is a little bit more difficult to use. You really need to like write the code, but here you just point and click.
Yeah.
But of course, if you are familiar with R, do use it. Use.
Yes, I am. I'm still learning R actually. I'm in the basics, but
yes.
Yeah, it's even the coding the R is not very complicated.
Yes, it is not.
Unlike, for example, Java or Python or anything like that. But
yeah,
yes.
I would say so. From the perspective of doing statistics, R is much easier than Python. Although many people say if you learn how to code, Python would be the easiest language to learn. But when it comes to statistics, I think R is like statisticians designed for statisticians. So it is for some basic statistical analysis, R would be a easier language to use and to learn.
Yeah, exactly. Yes.
Yeah. So does anybody have problems? So if everybody is downloading it okay, then I think maybe I can see you in 20 minutes, maybe. And then you tell me whether you have successfully downloaded it. Hello?
Yes, hello, doctor.
Hi, hello. Please call me George. It's fine.
Hi, we're here.
So has everybody downloaded the software?
Yes, I did download it.
Unfortunately, I haven't downloaded it because I'm not able to open my laptop right now. But I guess I will download it when we finish, inshallah.
Okay. I would just like to demonstrate how to use this piece of software, which is very user-friendly and it is free. So I know if maybe after you have graduated, or some of you are doing a PhD, I know, or if you don't have access to SPSS, then PSPP would be a great alternative to it. And it is freeware. So you can just download it and use it and without any consequences. And it is very user-friendly as well. So I would like to demonstrate two kinds of tests. And I'm going to share my screen with you first. So this is the question I'm going to ask. Does year of learning affect performance? So the longer you learn, for example, English, the better your exam score is. So this is my question. It has nothing to do with theories or any empirical studies. What I would like to demonstrate is the test we are going to use and how to answer this kind of questions using a statistical method. If anyone who has downloaded it successfully, sorry, I think I need to stop sharing my PowerPoint and then share my data set. Okay. Can everybody see now?
Yes, perfect.
Yeah.
Very
Yeah.
So I created some fake data in our break. And then first of all, you need to create some variables here in this tab, variable view. And then you type in your variables here. So I have year of learning and then the score. So the group, I will tell you what it is later. But for now, we just need these two variables. And then basically you type in the word and then press enter, and then type in the word, press enter, is created. Then you can go back to the here, data view, click on it. Then you can see the name of the variables here.
It's so much like the Excel.
Exactly, yes, yes. This part is very similar to Excel. But the different part is this part, how you create and define your variables. So you can just create your own data and then we are going to answer this question. Does year of learning affect performance? So we would imagine looking at the data here, year of learning, and the score. What is your assumption, your hypothesis?
That the longer the students have years of learning, the higher score they get, I guess.
Yes. So we are going to check if it is statistically significant. That means it seems like, yes, on the face of it, it is. But
Yeah.
we need something more precise to tell us whether
More
this
scientific.
observed, yes, this observed difference is significant or not. So we are going to click on analyze.
So, doctor, excuse me, how do you get this chart? Because I downloaded it.
Oh, I just created myself. I just entered the number myself, and so you can do it yourself as well.
I think you get it from the downloaded.
Oh no! I created.
No?
I created myself. It just took me 2 minutes to create the fake data.
So this is a normal Excel sheet.
You can think of it as an Excel sheet, but just there are some functions, because in Excel, if you want to do these types of analysis, yes, you need to type in some equations. which
Okay.
be, yeah.
So this is actually, so this is, I don't know where did you get it, okay, but you create, I'm talking about the blank sheet. Where do you get it from?
Oh,
I'm not talking about the number.
Oh, okay. So have you opened your software?
Yes, I opened it, yes, but I don't know how to get a blank sheet like this. And that's why I'm asking. I'm sorry, but and I'm really interested in this, but I don't know how to do it.
Okay. Is everybody having problems or basically?
No, it's okay for me.
Yeah, basically you just search PSPP and then you will get the software. Basically, you just search it on your computer. If you have successfully downloaded it, basically you just type the window.
Yes,
icon.
I got it. Thank you. Yes,
Okay.
excellent.
Okay, cool.
Excellent. Yes, I got it. Thank you so much.
Okay, no problem. Okay, so we would like to see the statistically significant, whether it is statistically significant. And then we are going to do analyze by varied correlation. So this is the test we are going to use. Then you may have something like that. Let's see, okay, can I make it bigger? You see all your variables on this panel. But you only want to find out whether year of learning correlates score. Okay. And then we just always two tails. And then okay. Then you will get a table like this. So has anybody seen it before? Like the correlation, like the R coefficient. Anybody know about it?
No, unfortunately, no.
Okay, no, no problem. So that is good. I'm teaching something. So yeah.
Yeah,
So
you
it
are.
is
You
it is
definitely
good.
are.
It is
Yeah,
good.
don't worry. Actually, this session is wonderful, to be honest.
Okay, cool. So there is a magic number that is 0.05. Remember this number and you will come across a lot. So whenever it is smaller than 0.05, it means your test is statistically significant. So I repeat, whenever you see the number here as smaller than 0.05, it means your test is significant. This is the result you want to see.
So I guess that we need to get a result that is less than 1, between 0 and 1, that is less than 1, right?
Yes. Here are two concepts. Yes, it is smaller than 1 in correlation test. We have, do you see, we have the score column here. Can everybody see it? We have three numbers here, 0.702.
No, actually, your screen only shows the data view and variable view. We don't see any additional columns.
Okay. Sorry, I have to stop it and then reshare it every time. Sorry about that.
No, it's okay.
Okay, can everybody see it now?
Yes.
Yes.
Yeah.
So you see the score column here.
Yeah.
Yeah, there are three numbers, 0.702, 0.024, and 10. So 10 is your sample size. We have 10 people in the data set. And then 0.024 in the significance two-tail row. That is what I talked about, the magic number 0.05. You want to see it below 0.05. Yeah, that means this test is significant. But how strong is it? So we say that, yes, the longer you learn, the better you can perform. But how true is it, you can ask, or how strong the effect is? And you can tell it by this number, 0.702. So this is a number between 0 to 1. The higher the number, the stronger the relationship.
Okay.
Yeah. So sometimes you can see it in negative. That means, for example, in our case, if you see it negative, that means the longer you learn, the worse you perform, which does not make sense. So it is a sign that you should look back your data and see whether you did something wrong with data entry, or the questions, you asked the wrong questions in the questionnaire, etc. So it tells you the correlation is pretty strong. So 0.702 is a very, very strong correlation in social sciences. So if anything about 0.5, it is very strong in social sciences. But you may also come across a situation where you got a strong correlation, but this significant row is above 0.05. So it doesn't matter how great this number is, as long as it is below 0.05, it is not significant. So the first number to look for, 0.05, above or below.
Yeah, so if at the end, if the score is above or below 0.05, then this is a satisfactory score in the social sciences and humanities.
This is what? Sorry.
This is like a satisfactory score, like a good score in the social sciences and humanities.
It is strong. So a rule of thumb is, if it is below 0.2, it is a weak correlation. If something between 0.3 to 0.5, it is like medium. If it is above 0.5, it is strong. So this is the rule of thumb.
Excuse me, if it's above 0.5, it's wrong?
Yes.
Okay, thank you.
But
strong, Giddy, strong.
Strong?
Yes.
Yeah, not strong, strong.
Thank you.
So it is pretty straightforward. I can show you the graph. Probably. Why is the score? here is X. Okay. Can you see the plots now?
Yeah.
Yeah. And you can see the dots here. It is basically like a more or less a straight line. More or less. If it is a complete straight line here,
Yes.
a perfect straight line here, then the correlation is 1. If they're all over the place, no pattern, and then very likely the correlation is 0. So it is how you visualize your data. You just plot the data points, and then you more or less understand whether it has a correlational relationship between the two variables.
And then the graph is done automatically if you just like click on it and that's it?
Good question. So I'm going to show you how to create the graph. I stop sharing here. And then I share here. Okay, so we go back to the tables here. You can go graphs, and then that is called scatter plots.
But why most of the researchers use the scattered one rather than the bar chart, maybe?
Okay, because you can show the relationship between one variable and another variable, whereas bar chart basically don't. They just show you, and then it also depends on, let me show you, maybe a good way of doing it is to show you why it is not as good as a scatter plot. Category access. Okay. I think I'm not sharing this. So you see the bar chart.
Yeah.
Yeah, you just count the number, basically. It doesn't show you the relationship. There is one person who study 1 year, or 2 person who study, one person who studied 2 years, and 1 person who studied 3 years. And then it doesn't show you the relationship. You just count the number. So I think I can go back to show you how to create a scatter plot. So we can go back to the spreadsheet here. But of course, if you want to count the number, a bar chart is a better tool. It depends on your research questions and the context and what you want to know. So we go to graph, scatter plots. And then normally we call the year of learning an independent variable, and then the score a dependent variable. Think of it this way: the year of learning affects the score, but how good you perform does not affect the year of learning. Is it clear?
Yeah.
Yes, it is. Yes.
Yes. Okay. So the independent variables always go to the x-axis. So the factors, or yeah, you can think of it as the factor. The factor always goes to x-axis, and what is being affected, so what is being affected is going to the y-axis. So because it responds to x-axis, or this score responds to the years of learning. So sometimes you also hear people call it responding variable. So just different name, but what is being affected go to the y-axis, and the factor go to x-axis, and then okay. Stop sharing, and then share the graph again. Sorry, it doesn't create. I cross it out and I do it again. Yeah, here.
Okay, George, can I ask you a question, please?
Yes, yes.
Okay, so can you bring the variable view on the sheet?
Okay. Yes. Can you hear? Can you see the spreadsheet now?
Oh yeah. Okay. So in the variable view, this is the data view. Can you bring the variable view?
Yes.
Yeah. So in the variable group, in the value labels,
yes.
Is this an equation that you put, or
okay?
Is this something you placed, or because
this is something.
I'm not with it.
This is something I created. It's good that
So
you asked this question.
Can you show us how? Yeah. Can you show us how you created that? Yeah.
Good. So this is what I'm going to show you next. But I will go through it in a few minutes. But please let me redefine my research question this time, or manipulate a little bit about the data first. Okay.
Okay.
So let's say this time, say 80, 70, and 65, and then 70 again, And then 50, 40, 30. Oops. So how about this time? Do you think there is a correlation between year of learning and your performance? So am I on data view now? Sorry.
Yes, you are on data view.
Okay, cool.
I don't think I can tell by just looking at the scores now. I need the statistic part.
Okay, so we are going to do it again, and then so I do it really quick and assume. Okay, yep. Then this time, okay, this time, can anybody tell me whether it is significant or not? So it is this table. Oh, sorry.
The screen is,
I think,
yes, the screen is still on data view. It's okay.
Sorry. And share. Okay, so this table, correlations. So just look at the number. Can anybody tell me whether it is significant or not?
I think it's not significant because it's higher than 0.05.
Excellent. Great.
Yeah, I'm happy that I got it. Yeah. Okay.
Excellent. But does it mean year of performance has nothing to do with year of learning has nothing to do with performance? They have no relationship. Can we say that?
No, nothing to do, but it's.
So there is nothing to do between the two variables. Can we say that?
So that means I have something wrong, right?
Not necessarily.
I think there is
though.
a correlation, but it's not significant.
So if it is not significant,
Yes.
there is
So
no.
there is no correlation. Yeah.
Exactly. So then, this is the next point I'm going to talk about. So I stop sharing here, and then I'm going to share the spreadsheet again. So you see the group variables here. Oh, sorry, the group variable here. Yeah, can you see the data view?
Yeah, we can see it.
Cool. So we go to variable view to see what the 1, 1, 1, 1, 1, 1, 2, 2, 2, 2, what are they? So we go to variable view. You can see I have the third variable group, and then variable label. This is what I would like to show you here. So I click on here, double click, and then you see value. I just delete it. So I do it again.
Okay.
So you double click here, and then if you do it yourself, you can see it is blank here. So you want to assign a value to a particular group. You see, if I want to say whoever studied less than 10 years, I assigned a number to those people. And so I assign number 1 to those people. and the variable label is below 10 years. And then I add. And then there are also some people who studied more than 10 years. So I assign a number to them as well. They are 2. And the value label is above 10 years, or maybe 10 years or above. And then add. Then, okay. Then if you go back to variable, go back to data view, and you can just add the data here yourself. So you just remember 1 is what and 2 is what. So I define 2 as above 10.
Okay. Yeah, I got it.
So everyone who learns more than 10 years. So 10 years, 11 years, 18 years, 20 years, 21 years, they belong to group 2. And whoever below 10 years, they belong to group 1.
Okay.
Yeah. So this is another statistical test I want to show you. If correlation doesn't work, don't give up just yet. You may be able to find significant results using another test. So this is analyze. And then compare means. The test you are going to use is independent samples t-test. So I hope everybody is clear. I just stay here like that for maybe a few seconds. So you go to analyze, compare means, and independent samples t-test, and click on it.
Okay.
So you want to know the score is your test variables. And yes, and then the grouping variable is group. And then you need to define groups. It doesn't matter, the order doesn't matter. You just need to put down what you assigned to this variable. You put 1 and 2. 1 and 2. 1 is below 10 years and 2 is above 10 years. So just the order doesn't matter. And then continue. Then you can click OK. Yep, then I need to share another screen again. There should be one table missing, sorry. Where is it? Sorry, I'll stop sharing for a while. I just see it in my own screen to see it. Oh, sorry, I need to scroll down. Sorry. It didn't allow me to scroll down when I was sharing my screen. Now I can do it again. Can you see the table at the bottom?
Yeah.
Yes.
Yep. So again, the magic number 0.05.
Oh yeah, 0
Yeah,
0.05.
0.05. So, and then again, look at this column, significance. So SIG stands for significance. So significance level, it is 0.002. So what does it mean?
It's
It is
insignificant.
significant, yes.
So it is significant.
Yeah.
So the number of years that you learn does have effect on your performance.
Yes.
But just correlation, the correlation test couldn't detect the differences or the significance. But if you use t-test, another test, then you will find it.
So, okay, so is there like do I choose the tests as I like, or is there something that compels me in the data, for example, to choose a specific test?
Okay, good question. So I show you two tests, and both correlation and t-test require continuous data. Continuous data means you can break down a number indefinitely. So you can, so 1, 0.5, 0.555, 0.11556, etc. So this kind of data, if you are dealing with this kind of data, you use correlation or t-test. If you are dealing with different data, different types of data, then you use another type of test like chi-square. For example, if you throw a coin, so it's either head or tail.
Yeah.
So if head is 1, and then so maybe you have a table. So if you got 1 score in this table, if you get a 1 head, you get 1 score in this table when you get 1 tail. So it can only be 1, 2, 3, 4, 5. It can't be 0.5 head or
it cannot be broken down. Yeah.
Yes, it cannot be broken down. So
Yes.
this type of number, we call it like categorical data or discrete number.
Yeah.
So if you are dealing with this kind of data, say the number of people who choose to do German in comparison with the number of people who choose to learn French. So you can't have half people, you can't have...
Yes, of course.
Yes,
Yeah.
so correlation and t-test would not be suitable for this kind of research design.
Yeah, okay, thank you.
Yeah. So what I would like to tell you is, if one test fail, if you fail on one test, or if you can't find something you want, then try another test. You may get surprised.
If I didn't get the results that I want, I can try another test, like what we did here.
Yes, and then it also requires you to recode your data as well. I just stop sharing this and share the spreadsheet again. So it also requires you to recode your data. So it does not exist. For example, if we get some scores and some data from the Education Bureau, from the government, and all we got is year of learning and score. So if correlation doesn't work, then we need to just like be smart and maybe recode the reorganize the data. Maybe if 2 groups doesn't work, how about 3 groups? How about 4 groups? And then, so it takes experience and it takes your domain knowledge as well. So as the saying goes, rubbish in, rubbish out. If you just blindly enter the data here and do whatever test you want, you may get significant results, but it doesn't mean anything.
Yeah.
So there are like the 2 ends. One end of the extreme is you get everything rubbish, but you still get significant result. And then other extreme is everything seems to be perfectly well, and then you still don't get good results or the results that you expected. Then you need to come up with another way to analyze your data. So you need to be more, you need to be flexible when you are dealing with data. The number of tests, the format, the design, they are quite standardized. There are only a few number of popular tests we use. Of course, there are more, but the number is like not that many. But in what situation you should use what kind of test is about your experience and your domain knowledge. So I think I have got my point quite clearly.
Yes. Thank you so much.
Yes,
okay.
yes, thank you so much. I just have one thing to ask you, if you don't mind, to send us like any manuals or any like resources that are elementary that are explaining also these kind of tests and the suitable tests for each research step by step. That would be amazing. If you don't
I'm not sure I understand you clearly, but you want to.
Yeah, I mean, like any, if there are any resources for that can help us to specific data, and also all the terminologies that you have mentioned. If you have any resources for them, that would be great.
Okay. Any resources? I can come up with a very good book written by Andy Field. He is great, but the book is that thick.
Oh wow!
So it may not be, and then
okay, maybe like a manual or a guide that is like for beginners.
Okay. I think if I were you, I would get yourself familiarized with the names first, and then you just Google the name.
Okay.
Because it would be very difficult for you to like to look at. It is very daunting if you have maybe 10 commonly used tests, and then you look at the menu and 2 of them are in front of you. Then it is a very frustrating experience. I would encourage you to look at the 2 tests we have just gone through today.
Okay.
And then you will come across a lot more tests related to those 2 tests. And then if you are still interested, you can look at the other names, and then you will understand more.
We have to start step by step, right?
Yes.
Okay.
But if you just want to know how to click the button, I have a very simple like a work document for some undergraduate students. I can upload it there.
Yes,
but
please.
But it explains nothing. It doesn't explain in what situation you use what kind of test, or it doesn't explain everything in detail. It's just a very simple guide for like a summary for some undergraduate students. I can upload it online.
Yes. Okay.
Later.
Thank you. We could start from it and then go deeper.
Yeah,
Exactly.
Yeah, this
Yes.
could be
Yes.
a starting point. Yeah.
Yes. So I hope it is helpful. And
Yes.
now it's 12 o'clock, and
Yeah.
I hope everybody learns something today.
We did. Thank you so
Yeah.
much. This was
Okay.
very interesting and very
That
enlightening.
was very
Thank you.